Hey guys, welcome back. So today what we're going to be looking at is sketching linear graphs. So specifically, we're going to be solving linear equations primarily using algebraic and graphical techniques. So really focusing on those graphical techniques. So to do that, we're going to graph linear equations using one of three different methods. We've got the intercept method, the slope intercept method, and graphing constant functions. What I would like you to do, I would like you to now go into that weekly check-in wherever you've got that saved. I want you to copy and paste your learning goal and success criteria into your weekly check-in. And I also want you to go in and I want you to define those three terms in your vocabulary. So x-intercept, y-intercept, and the gradient or the slope. All right, so let's jump in. Let's go through. So previously what we've done, whenever we've graphed something, is we've taken an equation, we've substituted in different values of x. So for this example here, I just picked values from 0 to 8. It doesn't actually matter which values you pick. And I just worked out what the y coordinate was going to be for each of those values. Then what I can do is I can plot those points, I can draw a straight line through it, and make sure that I've labeled my graph with the axes and the title. So you can see here on my graph, I've got the y-axis, I've got the x-axis, and I've got my line labeled as well. I'm going to get you guys to practice doing that for a couple of different graphs. So I'm only going to get you to practice A and B. So what you're going to do is you're going to take your rule, you're going to substitute in the x values, you're going to get the y values, and then from there, you're going to be able to draw a graph. All right, so now that you've given that a little go, what I want you to understand really is that that is such a long, boring, terrible way to do mathematics. So we've got three different methods, which are going to shorten that a little bit. Now, when we've done lines before, we know that you only need 2 points to draw a line. I mean, you should always do a third point just to double check that you have done the working correctly. But we're just going to find 2 points and we're going to draw a straight line through those 2 points. And this method is going to be so much quicker. So the 2 points that we're going to find are going to be the x-intercept and the y-intercept. So this is really good when you're not given lines that are in that slope-intercept form. So what I mean by slope-intercept form is when you have y is equal to mx plus c, because we know that m is already going to be our gradient and we know that c is already going to be our y-intercept. So if we weren't given something in that form, it's going to be a little bit trickier to work it out. So we can use three different examples here. I'm going to talk about the first one. Now, the first one is actually in slope-intercept form, which does make it easy enough for us to work out if we've done this correctly after I've finished plotting. So the first thing that I'm going to do, this is the intercept method. I'm going to find the x-intercept and I'm going to find the y-intercept. So to do that, remember the x-intercept, because you should have gone in with your definition. So your x-intercept is the point of the line where y is equal to 0, or in other words, where it's crossing that x-axis. So I'm going to take this here. So this y is equal to 3x, take one equation, and I'm going to show you how to find that. So first we're going to start off with the x-intercept. So remember when y is equal to 0. So substituting that in, 0 is equal to 3x, take 1. I'm going to move that one over to the other side, and then I'm going to isolate x. So we now have our coordinates. So the x coordinate is going to be 1/3 and the y coordinate is going to be 0 because that's what we let y equal to. Now we're going to do the same thing, except we're going to do it with the y-intercept. So since the y-intercept is where it crosses the y-axis, this is also the point where x is equal to 0. So let's write that in, x is equal to 0. Now for this one, we should be able to already see, because this is in slope-intercept form, that the y-intercept should be -1. But let's go through, let's just prove it. So y is equal to 3 lots of 0 minus 1, so therefore y is equal to -1. So we have 0 as our x-coordinate and -1 as our y-coordinate. Now I'm going to take this and I'm going to do this just a very rough sketch. So we're just going to pop some numbers on our axis here, and I'm only going to pick really small values because I've only got really small values here and here. So the first point that I'm going to do is this one here. So this is 1/3 0. So I'm going to go to about here and I'm going to draw a dot or a cross or whatever in that point about there. I'm going to do the same thing now with the y-intercept. So this is going to be at 0, -1. So that's going to be that point there. Okay, so I've got my straight line going through my 2 points. Now, this is obviously not the best drawing. I do apologize. So now you should be able to check this because this is in slope-intercept form, y is equal to 3x take 1. We can go in, we can double check that we cross through at -1, which we've already seen that the y-intercept is at -1. And we can also go back and double check that the gradient is going to be 3. All right, let's do another example. So let's do an example where it's not in slope-intercept form. So the second example I have for you is 2x plus y is equal to 6. So because this is not already in slope-intercept form, this is perfect for using the intercept method. So to do this, again, we're going to find the x and the y-intercept, and then we're going to draw a straight line through those 2 points. So I've just refreshed the page so that we have a clean slate. So let's go through, let's find our x and our y-intercept. So first, the x-intercept. So we're going to do this by allowing y to equal 0. Okay, so the x-intercept is when y is equal to 0. And we're going to substitute that value into our equation. So 2 lots of x plus 0 is going to be equal to 6. Therefore, x is going to be equal to 3. So let's write this as a coordinate. And again, we're going to have 3 for our x-coordinate and 0 as our y-coordinate. Now let's do the same thing with our y-intercept. So remember, the y-intercept is when x is equal to 0. So 2 lots of 0 plus y is equal to 6, therefore y is equal to 6. So writing this as a coordinate, 0 is our x-coordinate and 6 is our y-coordinate. So now let's go in and let's draw these points. This time I'm going to do a little bit of a different scale. So let's go to 10 and then to 10 on this axis as well. So this first point here, this x-intercept is going to be at 3, 0. So we're going to go roughly probably about here, and we're going to draw a little cross there. Then our y-intercept is going to be at 0, 6. So if that's about 5, that's going to be about 6 there. And again, we're going to draw the line. So there we go. That's roughly going through our 2 crosses. And again, let's just double check this. So the only way that we can really double check this is by putting this into slope-intercept form. So we've got y is equal to y is equal to negative 2x plus 6. So we're expecting this to go through the y-axis at 6, which it does, and we're also expecting this to have a negative gradient, which it does. So that means, or that suggests to me, that my line is accurate. All right, let's do our third example now. All right, so just refresh the page again. So as we can see, this one's also in slope-intercept form, so we can also double check it at the end. But first, let's do our x-intercept and our y-intercept. So our x-intercept, remember, is when y is equal to 0. So let's substitute that into our equation. So y is equal to 0. So 0 is equal to negative 3x minus 12. And let's just rearrange. So negative 12 is equal to 3x. So x must be equal to negative 4. So let's write this as our coordinate point. And now let's find our y-intercept. So y-intercept, remember, is when x is equal to 0. So substituting that into our equation, we should be able to see that it's negative 12. Y is equal to negative 3 lots of 0 minus 12. And look at that. There you go. It is perfect. And let's write this as a coordinate. All right, so now I'm going to go very rough with this one. So let's just do to 15, and then let's just do to 15, and then negative 15 on this axis, and negative 15 on this axis. Okay, so let's plot our first point. So our first point is at negative 4, 0. So I'm going to go along to about negative 4. So that would probably be about there. And then my other point that I'm going to go to is going to be 0, negative 12. So probably about here. Whoops. So probably about here. All right, now let's draw our straight line going through there. There we go. Okay, and just to quickly double check, we should see, because this is in slope-intercept form, that it goes through the line at negative 12, which it does, and then also it should have a negative gradient, which it does. So that is the the intercept method, and we've double checked that using the slope-intercept method. All right, so what I would like you guys to do now is I want you guys to have a bit of a go. So chapter 3.2 in your book's page 79. So there's a few questions there. I'm just going to get you to do the first column. So A, D, G, J, and M. And I'm going to get you to do that using the intercept method. So just to summarize, we find the x-intercept by letting y equal 0. We find the y-intercept by letting x equal 0. We plot our 2 points, and then we sketch our straight line. And I'll be back in the next video to show you how to do the slope intercept form. Talk soon. Bye.